Alright, today I'll be teaching you guys how to use normal distribution. Normal distribution is the probability theory for normal distribution. And it is a bell-shaped probability density function known as the bell curve. Now, to find the bell curve, we need to figure out, first of all, what numbers we're working with. And we're going to be using the problem, Professor Hard assumes that overall exam scores are normally distributed and wants to grade on the curve. The mean score was 58 with a standard deviation of 16. Now part 1 is we need to find, we need 14% of the students to receive an A. So we need to find the minimum score to receive an A so much that 14% of the students receive an A. And the second part is we need to find, we need 19% of the students to receive a B. So based on the minimum score for A, we need to find the minimum score for B on the bell curve. Now this is shown by the probability function. Probability Z is greater than C. Now C is the percent of students to receive a certain grade, such as 14% and 19%. Now, if we were to put this on a bell curve, we'd find that A is over here with 14%. Now, we need to find C1 over here. That is the minimum score we need to receive in order to get an A. So much so that 14% of the people receive an A. Now, we can't use the 14% here, because we'll find the maximum score, which will be 100% or whatever. Or it'll be the maximum standard deviation, or within 2. Now, what we need to use is on the right side of this graph, there's 36% left over after 14% receive an A. Now we need to find the maximum score we can get with 34% receiving below an A, because that'll bring us C1 over here. Now, C1 is therefore equal to 36%. Now that is 0.36. Now to find that the Z value of 0.36, we need to use a standard normal distribution table, which is actually Appendix F in your textbook. Yeah, it's on the left side, I believe you're looking at. Now we need to find 36%. That'll be found in the body and not on the sidelines. Now that will end up being 1.08. Now, to use that, we need to use the Z distribution formula, which is Z is equal to x minus the mean divided by the standard deviation. And the formula looks a little weird, I know, but now on the flip side, Z is equal to 1.08, the mean is equal to 58, and the standard deviation is equal to 16. Now, if we implement that on the formula, you get 1.08 is equal to x minus 58 divided by 16. Now, the work we actually need to do is on the other side. We need to multiply, or we need to get x alone. That'll be the minimum score to receive an A, where anything above that, or everyone else above that, will be the 14% receiving an A. Now we multiply each side by 16 first. That way we get rid of the 16 division below x. Now you'll get 17.28 is equal to x minus 58. Then we add 58 to both sides. Then you get x equals 75.28, or just 75 for 14% of the students to receive an A. So now that we found out what the minimum score is to receive an A, we can now find what the minimum score is for 19% of the people to receive a B. We will go back to the bell curve I drew earlier, where the rest will make sense. But okay, on this side over here, we have 14% of the people who received an A. We found out that C1 is equal to 75.28. Now that's the minimum score for someone to receive an A, or just 75. Now for B or C2 over here, that's the minimum score we need for people to receive a B. and 19% of the people need to receive that. Except we've already found 14% of the people who need to receive an A. So instead of just subtracting it for the 50% on the left-hand side of the, or right-hand side of the picture, we need to subtract that from the remaining 36%. You'll find 17%. That is the remaining. The maximum of the 17% will find us the minimum score to receive a B, and then therefore find the minimum score for 19% of the people to receive a B. Now we've found the 17%, we can find on the standard normal distribution table the C value. Now we found out that C is equal to 0.19. 0.17, sorry. Now, 0.17 is equal to 0.44. Excuse the error in the middle. It's actually 0.17 is equal to 0.44 in on the standard normal distribution table. Now we apply that to the formula that we used earlier. Z equals x minus the mean over the standard distribution, or 0.44 is equal to x minus 58 divided by 16. Now we just implement that again. You multiply each side by 16 to get rid of the division. So it'd be 16 times 0.44. You can use a calculator. This makes it a lot easier. I have it all written down beforehand. Now, 16 times 0.44 is 7.04. Let's see if I can get this correctly. Now, you end up with 7.04 equals x minus 58. Now you add 58 to both sides, and you get x equals 65.04, or just 65. Now you need at least a 65 on your test in order to receive a B. Now, that's the minimum score. The number from that score up to the maximum or minimum score for an A is the 19% of the people who need to receive, from 65 to 75 is the score you need to receive for 19% of the people to receive a B. And that's how the normal distribution applies to the problem. Professor Hard assumes that the exam scores are normally distributed and want to grade on the curve. The mean score is 58 and with a standard deviation of 16. We found the minimum score for 14% of the people to receive an A is 75, and we found the minimum score for 19% of the people to receive a B is 65. And that'll be it.